Hello and welcome to my explanation of my Action Mesh renderer. Here we're going to go ahead and take a look at how it kind of works, 3,000 foot overview of how I'm able to get game objects to render and render using different models and render using different materials dynamically, and also for it to be deserialized in such a way. So let's get into it. Let's go to the Action Mesh renderer.h, the interface. Let's cover some of these basic things. So in my framework, the action here it's something that a object can perform. Think about it like as a component that can perform something. It doesn't just hold data. And so this component is a renderer, so it performs the drawing. It has some basic methods here, like toString, which just gives it back the name of the class clone. You can think about that as a polymorphic constructor, copy constructor, equals. How do we compare to Action Mesh renderers? Initialize, the most important method in any object that can be deserialized, because once it's deserialized, you need to then kind of connect the wires and set it up. And that's where this comes in. So we're going to visit this in a minute. Some helper functions to get this class populated with data, because once deserialization happens, it doesn't really have anything, and then you need to initialize it. Of course, the great update call, the great update method, takes a game state which holds game time and queues for a bunch of things, holds most of the information, if not all the information objects will need in order to perform the update. The classic draw method. Here we have the constructors and destructor. Very important. Signatures used for kind of communicating to the deserialization process, like where data is located in the object. So that's like the signature of the data members of this object and where they're located relative to this object. A macro I created to register this class to the registry system. Components are visible, or it's important to make your components visible or not visible. Cameras, because when we end up moving the camera, or when we end up moving the object itself, the way it's presented to us, the way we see it, is going to change. So we need a reference. We need to have access to the camera consistently. So we're going to cache that pointer. And whenever we move anything, it's gonna be used. We need to get its transform. Private constructors, because possible inheritance in the future. Right now this is final. For now, I have DirectX members hard-coded into these classes. For the purposes of this project, it's DirectX based. I would like to separate it and make this not dependent on one like graphics API. But for now, this works. And then we have members that get data for the graphics pipeline, create the vertex buffer, create the index buffer. We have our world matrix, constant buffers per object. We have the input layout. We have the vertex buffer, index buffer, and constant buffers. Very important. These three are like the three very important data elements for like this Direct3D graphics pipeline. We have our color texture, which we really don't need here anymore, actually, because that's going to be handled by our material. So this needs to go. Vertex shader and pixel shader, there are classes for these that like contain the data for it and what stage in the pipeline they should perform work in. Index count, yeah. Anyways, these are cached pointers because this data is going to get accessed a lot. Material, this is the base class to materials, this is the base class to models, and of course the camera. And I made this because it's just one mesh of the model. Yeah, this material base class, very important. We're going to visit that soon. Okay, yeah, parent transform for, um, you know, hierarchical transforms. And when you call update, you need to get the parents transform and kind of concatenate that with your transform in order to get the correct transform. Then we have this macro, which is again for deserialization. Now, like I said, we're going to go visit the initialize method. Here we go. Call the base class's initialize method, which will register with the game. And then, yeah, I mean, at this point, there should be a throw exception in here, but for testing purposes, I just did this. Get pointer to the camera, get the Direct3 device for rendering. In our deserialized object, Action Mesh Renderer, there should be data that's for the model, so we go find it. And we find data for the material, so we go find it, we cache those. Yeah, and then we initialize the material, and then we create the Direct3D pipeline data in order to get this thing going. The vertex buffer, index buffer, and get the index count. Here we have some dirty bool pattern kind of things, which is like for hierarchical transforms and drawing of the function. Drawing of the mesh, because you don't want to call this all the time. You want to call it when either the material, when the camera moves, or when the object moves. Otherwise, there's no need to constantly draw this. You're gonna bog down your update call. Get the parent transform. Yeah, and then this is the draw. I'm not gonna go into detail about this too much, but yeah, and then create the index, create the vertex, and there's a lot of other little things I did here, but not really important right now. This is just kind of more implementation detail stuff. I think I covered a good chunk of what kind of happens here. Effectively, this is very important. Finding the model, finding the material here. So the cool thing about the material is that since we're accessing it through the base class pointer, since we're getting it as a material, we're getting it as a material. This could be, since the material is a common interface that all materials use, being at the base class interface, we can call the draw and all these other functions polymorphically and get the correct material. So this Action Mesh Renderer can support any material that shares that interface, the base class material interface. So that's good, because then we can deserialize different materials and have them in the Action Mesh Renderer. So in scene 5, you'll notice that game object 1 uses a point light material. And if we go to game object 2 also uses a point light material. But game object 3 uses a regular texture material. And when we click play, you'll see that the Action Mesh Renderer is calling the base class materials interface methods in order to get everything working. So that's nice. Get different materials in there is a big deal. Yep, but these guys are point light, and then this guy is regular texture. Yeah. Overall, that's pretty much a 3,000 foot overview of this. I know I've been pretty quick about it. But yeah, hope you guys enjoyed. Take care. Bye.